Hi, I'm Nachiket.
And I am Onkar.
We have developed a system that detects nearby objects using an ultrasonic sensor. When an object is detected, it triggers a blinking laser, which is then picked up by a light-dependent resistor area. This whole process helps detect obstacles and track their proximity.
Some areas on the earth, such as deep cracks, caves, or collapsed buildings, are difficult to humans to access. In this situation, we can send a small rover with our system to detect obstacles in front of it and measure the distance between them. This allows us to explore dangerous or unknown environments safely without putting humans' lives at risk.
In transmitter circuit, our system works by using ultrasonic sensor that emits sound waves and waits for an echo to return. If the echo comes back quickly, it indicates that there is object in the nearby area, and the sensor calculates the distance. Once the Arduino processes the data, it triggers the laser to blink, signaling that the object has been detected.
On the receiver side, we use an LDR that detects the light from the laser. When the laser hits the LDR, the light intensity increases and the system logs the detection. The system only logs the event once per the blink. To avoid redundant logging, it also records the time gap from the previous detection.
Now let's see how our system works.
The ultrasonic sensor sends sound wave to the bottle and the echo receives the sound back. The object detection information transmitted by laser to the LDR.
The object detection is shown on the receiver side serial monitor, and angle and distance is shown on the transmitter side serial monitor. This circuit diagram represents the transmitter unit of object detection system built around an Arduino Uno. It integrates three main components: a servo motor, an ultrasonic, and laser module. Here is the background of the connections and the functions. Ultrasonic sensor, which is HC-SR04, is connected at VCC to 5-volt pin on the Arduino. Its ground is connected to Arduino's ground. Trigger and echo pins are connected to two digital pins on Arduino, commonly at D11 and D12, allowing Arduino to send out ultrasonic pulses and measure the echo each time to determine distance. The servo motor is powered by 5-volt and ground pins. The control signal wire is connected to PWM digital pin, that is D6, allowing the Arduino to rotate the servo. And the laser module is also powered with ground and the D9 digital pin. Here it is the transmitter circuit.
This circuit diagram shows the receiver side of the object detection system using an Arduino Uno and an LDR. The LDR is used to detect the light from the laser module transmitted by the transmitter unit when an object is detected. The circuit forms a simple voltage divider configuration. One leg of the LDR is connected to 5 volt of the Arduino, and the other leg of the LDR is connected to the one end of the 10 kilo ohm resistor here, and also to analog pin A0 on the Arduino. This is the voltage divider output that the Arduino reads. The other end of the 10 kilo ohm resistor is connected to the ground here. Here is our ground. When the LDR receives the light, specifically from the laser, its resistance drops, which changes the voltage at the analog pin. The Arduino reads this analog value to determine if the light intensity crosses a certain threshold, indicating a detection event. This setup is simple, cost-effective, and ideal for detecting laser light with decent sensitivity. Our system continuously checks in one direction for nearby objects, detects them automatically, and signals the detection by blinking the laser. The system logs the detection and avoids repetition by resetting it after each event.
Our system is simple, accurate, and reliable for short range detection, and it helps to explore areas that are difficult for humans to access. That's our project. Thank you for watching.